Okay, so we want to learn how to make stereograms. Now, before we start, you see this pattern in front of you. There's a hidden object inside the pattern. Stare at it and see if you can see what's inside the picture. Okay, so what we do today is that we learn how to make stereograms. And this will be an example of functional abstraction, because what you do is that you learn to create this thing called depth map. And we have a function called stereogram, which will generate the stereogram, right? So you don't have to know how our stereogram generator works. You just take this depth map, stand it inside there, and you're done. Okay, so this is an example of function abstraction. So the stereogram generator is a black box. And you'll be generating something that looks like this. Okay, stare at this picture again and see if you can figure out what's inside. Okay, it's a heart. Okay, so before we start, let me just do a quick introduction on stereograms and tell you a bit about how they work. This is just for fun, okay, for general knowledge, will not be tested in exams. Well, it turns out that stereograms work because there is a small separation between our eyes, right? And because our eyes are separated, they see things slightly differently. And this gives us the ability to perceive that, okay? So what also stereograms do, which is the kind of stereograms that we'll make, is that they repeat patterns in such a way that our brains are kind of deceived into seeing some illusion of depth. So let's take a look. So suppose in this picture you see an object and there's an image plane. Think of it as a window, right? And you have two eyes. Now, if you look at this point on the object, okay, obviously light travels in straight lines, so you can draw light rays from this point to the two eyes. Now, over here, this ray will intersect the image plane at point A. Similarly, this ray will intersect the image plane at point B. Now you can draw a line, a ray from the left eye through B to this point on object. Okay, and then you can draw this ray back to the right eye. Repeat this until you have a whole bunch of points that all lie on the image plane. Now, what is so special about these points? Well, it turns out that because all these points are actually referring to the same point, then all these points must have the same color. So the key idea is to generate a set of points that are constrained to have the same color. Now, the interesting thing is that we don't have to compute everything at the same time. We can compute the required image one line at a time. So how do we compute these sets of points? Well, we use geometry. Well, first we create a 3D model of object. Typically, we use a fxy function to define the shape of the object, and fxy will give you the depth, right? So this is called depth map. And then you decide some parameters, for example, how far your eyes are from the image, how far the object is from the image plane, and also distance between your two eyes. Then you start computing the stereogram one line at a time. Okay, let's take a look. So first of all, you draw a ray from one point of the object to the left eye. Let's color it red. Okay, so you know at this point must be red for the right eye. Similarly, you can do the next point and so forth. Okay, so when you finish this, you have a bunch of red points. Now let's pick another point and make it green. Right, and similarly, you can repeat this and you have a bunch of points again. Now, if you do this enough times, you have a whole bunch of different colors all on the image plane. And this together will form the stereogram. Now the question is, how far is one red point from the next? Well, it turns out that you can use some math, okay, and essentially these are just similar triangles. So in our stereo generation program, we use grayscale to represent depth, where black is nearest to you and white is furthest away. So you have this Nova BB. This particular object refers to something 3D looks like this. So the Nike symbol thing is floating on top, right? And if you have this kind of object whereby the Nike symbol is the black on top and then the R cross VB is at the bottom, well, this is equivalent to this Nike symbol floating on top. Somewhere in the middle is this R cross VB, right? Okay, so what we can do is that we can use this new overlay command to put one rune on top of another one. So sail VB, R cross VB, overlay, you will get this. Note that the second rune is in the middle of the volume, right? This is 50%. There's also a new command that you can use called overlay frac, and like the stack frac, you can give it a fraction and 2 runes, and this allows you to control the depth of the second rune from the top. So if you do 1/4, it means that this height is 1/4 of the total height. Okay, and you can also do this thing called scaling. So you can scale the height by half, and you get a smaller height this size, right? So it's very simple. All you do is to create a depth map, which is just any rune, right? And then you just call stereogram, and this rune is used as the input depth map to the stereogram generator, and out comes the stereogram. Now, what happens if you cannot see stereograms? Well, think differently, right? So think about this picture. So two eyes are looking at this object, and essentially the two eyes see the object slightly differently. Okay, if you cover one eye, you will be able to see these parts. Now, if you cover this eye, you will see these parts. Well, one thing you can do is use filters to show one image to one eye, another image to the other eye. This is known as anaglyph. Well, we gave out 3D glasses to those of you who came to the briefing. Those of you who didn't come, not to worry. We have spares. You can send email to TA Daryl, and he has the spares, and he can arrange to pass you some of the glasses. All right. So how else can you create an illusion of 3D? Anyone knows what this is? Well, it turns out that another way to create an illusion of 3D is to use motion. So if you have one eye, then as you move the eye, okay, you will see slightly different images, right? So by computing a whole bunch of images and stitching them together, you can also create an illusion of 3D motion. Okay, so what did you learn today? Well, we covered functional abstraction. Essentially is to create functions. What are functions? Functions are like black boxes where you can call on them, right, and use them to create more complicated objects and other functions. You also saw assignment on naming, whereby we gave names to certain rune objects, like the make-cross. Okay, we created a new function called make-cross and call it make-cross, right? And note that functions are objects because we can pass them into other functions. Like, remember we did the repeat pattern. The pattern is a function, and we passed it into the repeat pattern function. We also touched on these objects called anonymous functions, and essentially these anonymous functions are created using the lambda command. Abstractions are important, and function abstraction is one of the different types of abstractions that you will learn in this class. The whole point of abstractions is to help us manage complexity, okay, by allowing us to focus on high-level problem solving. So that's it for today. Now the next thing to do is for you to go and do your missions. Alright, good luck. I hope you enjoy the homework. Take care and see you soon.